All right, so the first example we're going to do for split method is 3x squared minus 10x equals 8. So the first step to solving something using the split method is to make sure that it's in standard form, which is ax squared plus bx plus c equals 0. Okay, so right now it's almost there, but the 8 is on the wrong side of the equation. It needs to be equal to 0, and my constant needs to be at the end. So in order to move the 8 to the other side, I would need to subtract it, which means now I'm going to have 3x squared minus 10x minus 8 equals 0. Okay, step 2 is going to be to look for a GCF. Always look for a GCF. So on this problem, I have 3, negative 10, and negative 8. These don't have anything in common. Okay, so I don't have a GCF, and I can just skip that step. So the next step is going to be to use an x, and we're going to fill in a times c up top, and we're going to put b in the bottom. So for this example, a is my leading coefficient, so a is 3, b is negative 10, and c is negative 8. Okay, so b is going to go down here. And then a times c would be 3 times negative 8, which is negative 24. Okay, so now comes the challenging part. I need to come up with factors of 24 that would also add to be negative 10. So what two numbers could I multiply and get negative 24, but add and get negative 10? So for this example, I could do negative 12 and positive 2. Now, some of you might have been thinking 6 and 4, but they would need to both be negative in order to get negative 10, and two negatives would multiply to get a positive 24, so that won't work. When you're at this step, there's only one set of factors that will work for the problem. Okay? So now my next step is going to be to split b, so to take negative 10x and replace it with the two factors that I just came up with. So I'm going to have 3x squared minus 12x plus 2x minus 8 equals 0. Okay, so all we did was we took the 10x out and replaced it with both of these numbers. So we're not changing the value at all. Negative 12x plus 2x would have given me my original equation. Okay, so the next step now is to find the GCF of our first two terms and then find the GCF of our second two terms. And I have to actually factor out that GCF. So for our first two, our GCF would be 3x. And for our second two terms, it would be 2. So now when I factor this out, whatever my GCF is would go in front of the parentheses. And then we would actually divide both of these terms by 3x. So 3x squared divided by 3x would just give me x. And then negative 12x divided by 3x would be a negative 4. Okay, then my next term that I took out would go here, so plus 2. And then again, I would just divide and actually factor out the 2 from the 2x minus 8, and I would be left with x minus 4. The goal at this step is that whatever you have in parentheses is the same for both of them. Because now, if I look at this problem as a whole, what is the GCF that I can factor out? So the GCF would be x minus 4. Both of these have an x minus 4 as a factor. So when I factor it out, they would cancel, and what I would be left with is 3x plus 2. And that's the factored form for this problem. Okay, then to find the solutions, we would just take our factors and set them equal to 0, because I know if either of my factors is 0, anything times 0 will result in a product of 0. So I would set x minus 4 equal to 0 and 3x plus 2 equal to 0 and solve. So over here, I would just add 4. That's just a one-step equation, and x equals 4. That would be one of my solutions. Then for the second one, it would be 2 steps. I would need to subtract 2 first. So I get 3x equals negative 2. And then I would divide both sides by 3. So my second solution would be x equals negative 2 over 3. Okay, and we can always check our work on these. So you can take the 2 answers that you got and come back to the original equation and plug it in for x to make sure that it works out. So if I plug in 4, for x, it should equal 8.